Hi, I'm Beth from My Tutoring Bee, and in today's video we are talking about finding percent increase or decrease. I have a few examples for us, so let's go ahead and get started. All right, in our problems today, we are going to be using this proportion method that I've talked about before in previous videos. You can check those out in the description below where we have found either percent, the part, or the total, depending on what the problem gives us. And we're going to use that same method. However, there's an extra step in these problems. We are trying to figure out how much something has gone up, which is an increase, or gone down, which is a decrease, from beginning to end in each of these problems. So in order to do that, we are going to always take the new number, subtract the old number, and that's going to be our part, or that's going to be the numerator for our second fraction. We can also just call this the difference. Now, the other piece that I want to mention here is that instead of using the term total for the denominator, we are going to use original. So that just refers to the original number or the old number, whatever the previous number was. And let's take a look at this first problem to see where those numbers are going to fit into our proportion method. All right, we've got Miko had 27 bugs in her collection at the beginning of the school year. Now it's the end of the school year and she has 45 bugs. Find the percent increase or decrease of Miko's bug collection. All right, so let's take a look here. She started with 27 and now she has 45. So it looks like we're looking at an increase, right? Her bug collection has grown over the school year. So we still are going to find the difference, and then the denominator is going to be her original amount of bugs in her collection. So let's start off with that difference. So we've got the 45 that she has now minus 27. So 15 minus 7, that gives us 8. 3 minus 2, that gives us 1. Okay, so the difference, let's go ahead and set up our proportion here. The difference is 18 out of the original amount of 27. Now this number is still always going to be 100, and then the percent is the part that we're trying to find. So that's where I'm going to put our variable. So now this is just like all of the other percentage problems that I've done in some previous videos where we cross multiply and then solve for x. So 100 times 18, that's 1,800. X times 27, that's 27x, and then we're going to divide by 27 so that we can solve for x. Divide by 27, divide by 27, that cancels that out there. Okay, so let's see, 27 can't go into 1, can't go into 18, it can go into 180. 27 is pretty close to 30, so 3 can go into 18 6 times, so let's see what that gives us when we do 27 times 6. 6 times 7 is 42, 6 times 2 is 12, plus 4 more is 16. So 162, that works, and let's subtract that here. That gives us 7, and then 10 minus 2 is 8, 7 minus 6 is 1. So we wind up with 180 again. So that means that this is going to be a repeating number and a repeating decimal. This goes in 6 times again here into 180. We're just going to continue getting 6. So I'm going to go ahead and put my decimal 6 there and put that bar over the 6 to show that that is a repeating 6. So our percentage here would be 66.6% increase. Let's go on to another problem here. The high temperature for today is 85 degrees Fahrenheit. The low is 63 degrees Fahrenheit. Find the percent increase or decrease from the high to the low. So since they are asking us from the high to the low, then that means that the 85% is going to be what we consider our old or original number, and then the 63% is going to be the new number. So we want to go ahead and find the difference. Now notice that I am just taking 85 minus 63, even though 85 is the old number. Basically, we want to just take the highest number and subtract the lowest number. We just want to find the difference or the distance between these two numbers, whether we're going with an increase or a decrease. For this one, it does look like we're doing a decrease because we went down in temperature. So let's figure out what that difference is. So we've got 22 degrees. Now let's set up our proportion. We've got the first fraction over 100 and then the second fraction. Now our difference is going to be the numerator, and our original number, 85, is going to be the denominator. And then again, we're trying to find the percentage, so that's where our variable goes because we don't know what that percentage is yet. And then let's go ahead and cross multiply. So we've got 2,200 equals 85x. And then to solve for x, we're going to divide by 85. We're going to divide on both sides. That's going to cancel that 85 out there. So let's see what that is when we divide 85 into 2,200. Okay, 85 can't go into 2, cannot go into 22, but it can go into 220. So I'm going to guess about 2 times since 85 is kind of close to 100, 220 is kind of close to 200. So let's see what that gives us when we multiply this by 2. Let's see, we get 170. So yeah, I think that's as close as we're going to get. Let's go ahead and subtract that. So we get 50, bring down our 0. So let's try 5 times 85 times 5. That gives us 25, 42, so 425. And 5 times here, 425, and then let's subtract there. So we wind up with 75, so we're going to need to add on a 0 here. And for this one, the directions don't say to round to any particular place value, so I'm just going to go ahead and round to the nearest percentage. So I'm just going to go one more digit here. Let's figure out how many times 85 can go into 750. So let's see, I'm going to try 8 times, so 85 times 8. So that's 40, 64, 68. Okay, so that's 8. And we just need that extra digit so that we know how to round to the nearest whole percentage. So that's going to round up to 26%. And this is a decrease. I do have a few other examples for us, but I just wanted to take a quick second to say if you like this style of teaching, you can find a ton of my other videos in the description below. I also do offer tutoring, one-on-one tutoring online. So if you are a teacher or a parent who has a student in need of some extra help, then please reach out. I'd love to see if I can help you. All right, let's get started on these other problems. Okay, here we have a juice box claims to have 30% more juice now than it did before. If the new juice box has 26 ounces of juice, how much juice was in the original juice box? Okay, so in this problem, they are giving us the percentage that it sounds like it has increased for this particular problem. They're giving us the percentage, but we want to know what the original amount was. So let's kind of visualize what that looks like for this particular problem. Here is our new juice box, and 30% of this is new, is more, right? So that means that this was the size of the original juice box. So the original juice box was 100%, right? At the time, that was all of the juice that was in there. And then they took 30% of that and added it on top of the 100%. So let's think about that in terms of percentage. So now our juice box contains 130% of juice, right? Compared to the old amount or the original amount of juice. We also know that this juice box contains 26 ounces. Okay, so when we are setting up our proportion here, we need to keep these two numbers in mind that they go together, right? 26 ounces represents 130% of the juice. So let's see what our proportion looks like. Now, we're again using this same sort of setup for our proportion, but let's redefine some of these terms. Instead of just the percent, we don't want to use 30%. We want to use the combined percentage. And same with the part. We actually don't know how many ounces exactly this is yet, so we want to use the combined ounces, which we know is 26%. And then for the total, that's going to be the original amount, and that's the part that we don't know, so we're going to use our variable in that spot. So we still are using 100 as our denominator here. Our combined percentage is 130%. Our combined ounces is 26, and we don't know what that original amount is. So now we can go ahead and do our cross multiplying. So 100 times 26 is 2,600. 130x over on the other side, and then we're going to divide by 130. Divide by 130. We can take a little bit of a shortcut here. Whenever we can reduce a fraction before we divide, that might make things a little bit easier. So I'm just going to reduce both the numerator and denominator by 10. And then let's divide. Let's see what we get. So we got 260 divided by 13. Well, 13 can go into 26 2 times exactly. So that is 2 times 13 is 26. And then 13 can't go into 0, so we get 20. So then that means that the original amount that was in the juice box was 20 ounces. Okay, for our last problem here, we've got a video game is marked 35% off. If the original cost of the game is $60, how much will it cost on sale? So this is a pretty classic percentage example, percent increase or decrease. We are obviously decreasing with this one because the amount is going down. So let's figure out how to solve this one. Now, this 35%, a lot of times we'll see that and we'll want to go ahead and put that in the fraction over 100. However, let's think about what we are actually trying to find here. We want to know how much it will cost on sale. So we want to know what is the percentage that we are paying for. 35% is the percentage that we can take off of the price, but then what's left over? What are we actually paying for? So that is one way to look at it. The other way that we can look at it is we could go ahead and find that 35%, and then that's going to be the amount that we would take off of the $60. So then we could just do 60 minus whatever that 35% is. So we've got two different options here. What I prefer to do is go ahead and calculate the percentage that I'm paying for. So 100% minus 35%, that gives us 65. So we are paying for 65% of the price of the game. So that's what I'm going to calculate here. So we've got 65 over 100 equals, and then we don't know the actual price that we're going to pay, what that 65% is, but we do know that the total or the original amount is 60. All right, let's go ahead and cross multiply. 65 times 60. Okay, I know that 0 times everything is just going to be 0, so I'm going to drop down my 0, and then 6 times 5 is 30. 6 times 6 is 36, plus 3 more is 39. So we get 3,900 equals 100x. I also really like this method because now this makes it really easy to divide. We're going to divide by 100, divide by 100. Whenever we are dividing by 10, 100, 1000, anything like that, we can just move those decimal points over to the left. So we wind up with 39 equals x. So that means the game will cost us $39 after it's on sale. And that is how you do percent increase and decrease. Thanks so much for watching. I hope that this video was helpful for you. Please take a look at the description below. I have some links in there, including a link to my pre-algebra series, which this video is a part of. It goes over a lot of different topics that you would see in a typical pre-algebra class. So if you would find that helpful, please check that out. Also, don't forget to like and subscribe and leave me a comment. Let me know what you thought. Thanks so much. See you next time.